Good afternoon, everybody. Just let me know if you all can hear me, please. All right. So, good afternoon, everybody. Now, just to be clear, right? The class that I'm having today is physics, CSEC physics, huh? Right? So, the maths is always going to be on a Tuesday or whenever I have time during the day, right? But today, which is Wednesday, it's going to be physics, right? So just keep that in mind. Um, So I know I may have one or two students from my online class here, right? But for those of you who don't know me, right? Um, I don't teach in any school, right? I've been an electrical and computer engineer for about 17 years, right? Um, I'm also a past national scholarship winner in Trinidad here, right? Science scholarship, that is. And I also got the highest mark in A-level chemistry a long time ago, right? And I was Cambridge. We didn't have KEEP at that time, right? And I'm also the author of several books you may have seen around, right? More specifically, since we're doing physics today, I am the sole author of the CAPE Physics Unit 1 and Unit 2 study guides, as well as a workbook for CSEC, right? Um, Now, this physics crash course is going to focus more on the topics, the broad topics that CXC has indicated to us, right? That is what this is going to be focusing on. So, in today's session, what I'm going to be focusing on, I'm going to be working on graphical work, analysis of data, deformation, and turning forces, right? Those are the three things that I plan to cover in class today. Now, the first thing you guys need to know, right? You need to be able to tell me what is Hooke's law, right? So don't be surprised if you see a question like that in your exam, right? When it comes to CSEC physics, right? There are different components of the exam. You have definitions that you need to know, and you need to know your definitions precisely, right? What I typically tell my students in class, no old talk, please. We don't want to old talk. We want to give exact definitions. So when they ask you what is Hooke's law, you need to be able to state exactly what is Hooke's law. Not in your own words, nothing like that. Exactly what you see I've written here is what you need to write in order to get that full marks, right? So Hooke's law basically states that the extension is proportional to the applied force provided that the elastic limit is not exceeded, right? If you are asked to write an equation to represent Hooke's law, what you're going to give them is this. You're going to tell them that F is equal to KE, right? Where F is my force in newtons, right? This K here is what we call our spring constant. So this is what we call our spring constant. And this E here is our extension, right? And that's usually, it's supposed to be meters, right? But when we do experiments with Hooke's law, the measurement could be in centimeters or even millimeters, right? So if I were to draw a graph, right, to represent Hooke's law, if I were to plot force against extension, right, my graph is going to look like this. It's going to be a straight line initially, right, up to a point, right? And then it's going to start a curve like this, right? So if this is my origin, this point A here, right? You have a point A and you also have a point B on this graph, right? The point A is what we call my limit of proportionality. right? And the point B is what we call my elastic limit. Now between O and A, right, that is my my linear region of the graph, right? It's a straight line region. So between O and A, Hooke's law is obeyed, right? Beyond beyond A, sorry, right? The curve, it starts a curve, right? Now there is a point called my elastic limit, and beyond that point, what happens is that you get permanent deformation of your spring or whatever material you are trying to stretch, right? Now just remember what Hooke's law is basically. Basically, you have, let's say, a spring, right? And you might have some weights being attached to the spring, and you have a pointer here, and we have a ruler on the side here, right? So every time you add a weight, you're going to get an extension, right? That's essentially what Hooke's law is about. Now, keep in mind that in the exam, the graph can be drawn slightly differently. The graph can be drawn like this. Instead of plotting force against extension, we can plot extension against force. In which case, what happens is that the graph is still a straight line, but it curves differently. It curves this way, right? So keep that in mind, right? Because sometimes in the exam, you can see variations of this type of graph in the exam, right? So here's what I'm saying. You need to make sure you know what is Hooke's law. Hooke's law states that the extension is proportional to the applied force, provided that the elastic limit is not exceeded. That's what CSEC wants. Write that. You're going to get full marks for that, right? Now, next thing we need to know now. I'm going to be looking at an exam question, by the way, here, right? So this is January 2008. So I suspect that you may be getting a data analysis question based on Hooke's law. That's just a possibility. They could bring that, right? So let's look at this question here. A student is investigating a relationship between extension and force. So from the time you see extension and force, you already know this question is about Hooke's law, right? They gave us the original length of the spring, which is 60 centimeters, right? So remember, if you have a spring, the spring may have had an original length, right? So let's say you have a spring here, right? And nothing is attached to the spring. Then the spring is going to have an original length, which in this case they are telling us it is 60.0 centimeters. So that's my original length of my spring, right? Now, they give us a table here. So you keep adding masses to the spring. So you start with 20, 40, 60, and so on. So you're adding masses to the spring. Now pay attention to your units. That's important. This here is mass in grams, but what they want us to write down here is what is our force in newtons, right? Now, if you want to convert from grams to kilograms, right? If you want to convert from grams to kilograms, we need to divide by 1,000, right? So if you want to convert from grams to kilograms, we need to divide by 1,000, right? That's what you need to do. So therefore, 20 grams, right? So 20 grams is going to be equal to, you divide it by 1,000, so this is 0.02 kilogram, right? So that's what my 20 grams is in kilograms, right? Now here's what they told us. They told us that the acceleration due to gravity is 10 Newton per kilogram. Now if you get a question on Hooke's law, this is a formula that you need to remember. Your weight is equal to mass multiplied by whatever my gravitational field strength is. So for this particular reading, the 20 grams, that is actually 0.2 kilograms. So it's going to be 0.02 multiplied by g, which is 10. So therefore, this here is 0.2 newtons, right? So pay attention to this conversion. Don't get confused. In the formula, W equal to mg, that's how we find weight. It's mass in kilograms multiplied by 10, but they gave us mass in grams. So I need to take the 20 grams, convert it to kilograms, which is divided by 1,000, so that's 0.02, and I need to multiply by 10. So when I multiply by 10, I'm going to get 0.2 as my force in newtons. So you're going to do the same for all the other readings. So this is going to be 0.4, right? Then this is going to be 0.6. This is going to be 0.8, right? This is going to be 1.0, and this here is going to be 1.2. So please, please, please pay attention to your conversion, because if you make a mistake here, then you're going to have problems with the answers, right? Now, let's look at what we need to do now. So we need to find the extension of the spring. Now remember, in the question, they told us the original length of the spring. That's the length of the spring, whether we have anything or not. Once we have nothing on it, that's the length of the spring. So therefore, if I'm getting a final length, look at this. This is final length. I'm getting 60.5. It means that the actual extension is really 0.5 centimeters. All I did there was take 60.5 and subtract 60.0, right? And then you're going to do the same thing for all the other readings. So what you're going to get here is 1.0, then you're going to get 1.5, then you're going to get 2.0, then 2.4, and then 3.0, right? So you're getting a little 4 marks here just to do this, just to complete the table. So keep those things in mind. You need to, in this case they wanted force, so we had to use the formula for weight in order to determine the force, right? Now, what do they want us to do now in part B? So in part B now, and look how much marks there, 10 marks there, 10 marks for this. Plot a graph of extension versus force. So you want extension versus force, right? So let's see. This is extension, this is force. So what I've done here, I've actually I've chosen a scale to use already. Keep in mind, when you're choosing a scale, you need to choose a scale so that it is able to accommodate all your data, right? So in terms of, they told us, let's go back here. They said plot a graph of extension against force. In physics or in maths, when they tell you plot something against something, this is going to be my y value and this is going to be my x value. So keep that in mind. So some students might read this wrongly and plot the wrong thing, right? But it's extension against force. So extension, if we go back to our extensions, our smallest extension is 0.5 and the largest is 3.0. So on my graph here, right, I chose a scale so that I'm able to accommodate from, look, 0.5 and then as high as 3.0 as my extension, right? In the case of the force now, you're going from 0.2 to 1.2. So if I go back to the graph, look, I'm able to cater from 0.2 to 1.2. So my scale, right? So sometimes students ask me, sir, do you need to put a scale? If you know what your scale is, just put the scale in, right? So on your x-axis, what I'm using here is 2 centimeters represents 0.2 units. 2 cm represents 0.2, in this case here is Newton. Or you could say 1 cm represents 0.1 Newton, right? And my y-axis is this. 2 cm represents 0.5 cm, 0.5 centimeters, right? So that is my scale that I'm using, right, on my x and my y-axis. Now, when you're plotting a graph, certain things you need to pay attention to. First thing, make sure and label your axes. So put extension and you need to put a unit. Don't just put extension, you're getting marks for writing on what unit you're using. That unit can be found from your table. In your table here, look, this information is right here. So if you're having trouble trying to figure out what you're going to plot, just look at the table. The table says extension in centimeters. So that's what I did. Extension in centimeters. You could write the word extension or you can just put exactly how you saw it in the table. E/cm. In the case of my y-axis, look, you have force in newtons. So you can write the word force newtons or you can just put F/newtons, right? So there's a unit here, right? So you must label your axes on your graph. You're getting marks for all those things. Next thing, we need to plot the points. When you're plotting points in physics, right, we either use a dot with a circle around it or we use a small x, right? It is totally up to you. But don't go in the exam and do something like this. You put a dot, I've seen students do this, a dot and one big circle like this. Don't do that, please. The size of that circle is actually supposed to be less than half a small square. It is a very, very tiny circle that you need to draw, right? So that's that. But because of how I'm drawing this here, I'm just going to use a dot to represent my points, right? Because the graph can get a little cluttered if I use either the x or the dot with the circle. So let's go and see what we're going to plot. So the first value that I'm going to plot is 0.2 and 0.5. So 0.2 is my force and 0.5. So this here, I'm going to put a dot here. That's my first point that I'm going to plot. You all are getting marks for plotting your points accurately. So be careful. So that's 0.2 against 0.5. The next one is 0.4 against 1.0. So let's go 0.4 against 1.0. That's this value here. Next value is 0.6 against 1.5. 0.6 against 1.5. That's this value here. Right? 0.8 against 2.0. So 0.8 against 2.0 as here. Then 1.0 against 2.4. So 1.0 against, one second guys, let me just check something here. So I feel I have a slight error. I missed my scale. Let me just fix this one time. I just have these numbers in the wrong place, right? So let me just fix that. Right, so let me just double check that. 0.5, 1, 1.5, 2, 2.5. Okay, so let me just, I just need to plot over these points, right? Let me just make sure that's correct. Alright, so let's do over this, right? 0.2 against 0.5. So 0.2 against 0.5 is this point here. Right? 0.4 against 1.0. 0.4 against 1.0. 0.6 against 1.5. Right? Next one is 0.8 against 2. So 0.8 against 2. 1.0 against 2.4. So 1.0 against 2.4. 2.4 is actually this point here. And the last point is 1.2 against 3. So 1.2 against 3.0. Right? So what I've done there, I have plotted the points. The next thing you guys need to do, you need to draw a straight line that passes through these points. So that's what I'm going to do. I am going to attempt to draw what we call a line of best fit, right? So if you all know what a line of best fit is a straight line that passes through most of your points, right? So please, when you go in the exam, use a sharpened pencil and using a transparent ruler. Don't go with those wooden rulers in the exam, please. Use a transparent ruler because you need to see how many points lie on either side of your graph. Right? That's what you need to do. Make sure you can see points on either side of the graph. Right? So this is my graph. 10 marks for this. Right? Simple enough. Right? You need to make sure, label your axes, choose the correct scale, right? And you're drawing a line of best fit. So that's 10 marks just for that. Next thing they want us to do is to find the slope of your graph. So you just plotted a straight line. So therefore we need to be able to find our slope, right? Now, what I usually tell my students, I tell them that we should choose 2 points that we have not plotted, right? Now there's a reason for that. Your line that you've drawn is what we call your line of best fit. It represents all of your data. That's what it does. All of my data is represented there, right? So what you need to do, you need to choose 2 points that you have not plotted, but choose those points so that they are far apart from each other. So what I'm going to do, let me use a different color here so you can kind of let's choose green. So what I'm going to do, I'm going to choose, let's say this point here. Let's say this point here, right? You need to know what that point is. So that point is actually 0.3, comma, right? And that point there is actually 0.75, right? So that's the coordinate of that point that I've chosen. Then I need to choose some other point right, that I did not plot. So I'm going to choose, let's say here, right? I'm going to choose this point here. So this point here, that coordinate is going to be 1.1 comma, right? And that point there is 2.75, right? So that's what you're gonna do in the exam. You're choosing 2 points that are far apart, but not points that you plotted, right? So get into the habit of doing that. Now let's go back here now. So what CXC expects us to do, you need to be able to show what are those points that I'm using, right? So the first point was 0.3.75. So the first point is 0.3 comma 0.75. That's my first point. My second point that I've chosen on the line is 1.1 against 2.75. So 1.1 comma 2.75, right? So I've chosen 2 points. Next thing I need to do, and I always tell my students to do that, so get into the habit of doing that. You need to label your points. Call this x1, y1. Call this x2, y2. It doesn't matter which one you choose to call x1 or x2, but just be consistent, right? Next step, you're going to write down, they said they want slope. So the slope, right, S, right, there's a formula for slope. Slope is gradient, right? And from your maths, you should know that slope or gradient is y2 minus y1 divided by x2 minus x1. That's how we find slope. So all we are going to do now is to substitute my values into this equation, right? So this is going to be 2.75 minus 0.75 divided by, and you're going to take x2, which is 1.1, right? Subtract 0.3. Now, lots of students, when they try to work this in their calculator, they get a wrong answer, right? So what I suggest you do is to work out the top part first. So 2.75 minus 0.75, you're going to get 2.0 divided by 1.1 minus 0.3, you're going to get 0.8. And then you're going to write down what your answer is, right? So then I'm going to say my slope S, so use your calculator, so that's 2 divided by 0.8, and I'm going to get 2.5. So it's 2.5, right? And sometimes they may ask you for the unit. I don't know if they ask us for the unit here, but because you are dividing, if you go back to your graph, you are dividing centimeters and newtons, right? So my unit, that sometimes CXC asks you that, so my unit in this case will be cm n to the minus 1, or you can write that as S is equal to 2.5 cm slash n, right? Any one of those will be fine, right? They don't ask you for the unit all the time, but if they do, that's how we get the unit. Let's see, Faith is asking if there's a mark for putting a title. Honestly, I don't think CXC is going to give you a mark for putting a title, but if you do have the time, go ahead and put it in. There's no harm in putting it in, right? All right, so we have the graph and we have the gradient. So that's a lot of marks gone already, right? So 10 marks for the graph, 4 marks for the gradient. Let's see what else they want. So now they said the spring constant is related to the slope according to this. So they want, what is the spring constant? So my spring constant, so they're actually telling us what the spring constant is, right? They say here what? Spring constant is 1 over my slope, right? So 1 over my slope is 1 over the answer that we just got, which is the 2.5. So it's 1 divided by 2.5, right? And that's going to give me, use your calculator for that, 1 divided by 2.5, and you're going to get 0.4. So 0.4, but remember the slope was given as 2.5 centimeters per Newton, right? So what you're doing now, and that's the same as saying centimeter slash Newton, right? But if you want 1 over the slope, what is going to happen is that the unit is going to change. It's going to become centimeter to the minus 1 Newton, right? But how we normally write it, we write 0.4, right? Newton cm to the minus 1, right? So this is typically how we write our spring constant. We write the Newton part first, and we write the extension part after, right? So if you remember at the beginning, I said your spring constant here, oh, I didn't give you the unit. The unit is usually Newton per meter. So spring constant is usually given as Newton per meter. But in this particular question, everything was given in centimeters, so we're going to give the spring constant in Newton per centimeter. So that's part D for 2 marks. The next part now, which is typically what they will do if they give you a question like this, draw a label diagram showing the apparatus used to do this investigation, right? So what you will do, you will draw something like a retort stand, right? You're going to put your spring here on the retort stand. You're going to draw your spring, right? Then you're going to put something where we can put our weights, right? You're going to need a pointer, right, which will allow us to get some measurements. So you're going to draw a ruler on the side here, right? So they're telling us to draw a label diagram. So don't just draw the diagram and expect to get the marks. Right? So this is my basic diagram that I need to use in order to investigate Hooke's law, right? So this here is my meter rule. So this is my meter rule, right? This here is my retort stand, because you need something to hold up the spring, right? So this is my retort stand, right? This is your spring that you're doing the investigation on. So this is my spring, right? This here, right, is going to be my weights that I'm adding, right? And that's basically it, right? That's all you need in order to be able, they didn't say to describe anything, they said draw a label diagram showing the apparatus as used in investigation. That's it, right? The next part, with the aid of dotted lines on your graph, right, determine the force. So they want to know the force which would cause an extension of 1.8. So what they're really trying to do is to tell you here what, use the graph, and we're going to take some measurements from the graph now, right? So we have an extension of 1.8. So when CSEC says draw appropriate lines, what they want here, they want you to draw some dashed lines. So let me just get a line to begin with. So let's see, let's make this red, make him a little thicker. Let's make him dashed. Alright, so this is a line here, right? And what we want to get? We want to get the extension, determine the force which produces an extension of 1.8, right? So we need to figure out where is 1.8 on this diagram, right? So let me, hold on, let me just get some more of these lines first of all. Right, so let's just keep this here, keep this here. So we want 1.8, right? So you need to go to your graph and you need to read off where is 1.8 on that graph, right? So that's the first thing we need to do. So let's see. First of all, we need to understand our scale, right? You definitely need to understand your scale. Now, according to the scale here, right, you're going from, this is 0 here, and you're going to 0.5. So that means that this is, let's see, this is 1, 2, 3. I know it might be kind of hard to see on the screen, right? But every 2 lines represents 0.1 centimeters, right? So if you want to get to I go back again, what it is, 1.8. You want to get 1.8. So let's go to 1.8. So look at something here. That here is, one sec, let me just get this a little better for you all. Right, so that's 1.5, right? This here is 1.6. This here is 1.7. And then when we go up a little further, this here is 1.8. That's where 1.8 is. So that's my line that they're talking about that you need to draw. That is 1.8, right? Now, we need to drop a vertical line in order to read off that value, right? So, what you're going to do, you're going to do this. This is the vertical line that we are going to drop here, right? And if I read off that properly, that is probably about, that's 0.6, 0.7, 0.72, maybe about 0.74, right? 0.74. That's what I'm getting from that graph there. So this here is about 0.74 Newton, right? So that's the lines that we need to draw. Those dashed lines you saw me draw there. You need to draw it on the diagram. You get marks for that, right? Obviously, your accuracy is going to depend on how you draw the graph. So I can get an answer and you might get something slightly different, right? It depends on how you draw your line of best fit. Now, the next part now that they want to know in part 2, estimate the extension of the spring. So you want extension now, but they're telling us that we're using a force of 1.3 newtons. So you gotta go back to the graph. You need to figure out where is 1.3 newtons, right? 1 point. Right, so 1.3 newtons, right, is actually about here. This is 1.3 here. So you're going to read off this value here. And when I go to my graph, right, you're going to read off whatever this value is here, right? So that value there is going to be, if that's 2.5, this is 3.0, it means that this here is actually 3.5. So this reading here is going to be 3.25, right? So that's that reading here, 3.25. So therefore, this here is going to be 3.25 centimeters, right? Notice again, 2 marks to do these things. You get the marks for drawing the lines on the diagram. Alright, so I hope you all following what's going on here, right? If you all haven't done so as yet, please hit like and subscribe to my maths channel, right? Oh, we still have a next part here, right? They said if the student continues to take readings, a point may be reached where proportionality no longer exists. Name this point, right? So that point, right, now here's the thing. CSEC kind of interchanges the word elastic limit and limit of proportionality, right? They use the term interchangeably. So what I'm going to put here, I'm going to put elastic limit, right? But the actual answer is limit of proportionality, right? So 1 mark for that, and that's our data analysis question here for 30 marks, right? So I have a second one to do with you guys here. We're going to look at that one as well. So in this previous question here, what we looked at in terms of the table, you realize we had to work out the force and we had to work out the actual extension, right? So let's see what's happening in this next question. I think this one's slightly different. So this is June 2000. A student investigates the properties of a spring and obtains the following results of the variation of length of the spring with load. So what they have done here, this is not extension. This is actually the whole length of the spring we're talking about here. So here's what they said. Use these values to plot a graph of length against load. So always remember, when you see the word against, that means that this here will be my y values and this here is going to be my x values, right? That's what that is. Now, let me get this close to my graph paper, right? So this is my graph paper here, right? So this is my data, right? So let's see. Right, so we have load and we have length, right? Load and length. And we're plotting, this told us we're going to plot length against load. So length against load actually means this, right? You're plotting length against load. That's what that means, right? Now, the first value that we have here in our table is 4 newtons and 18.4 millimeters. So 4 newtons, 18.4. Now, before you can plot these things, you need to make sure you understand your scale that you're using, right? Now, on the scale here, on both axes, I'm using 2 centimeters to represent 4 units, right? So on the scale here, you have, this is going to be 2, right? That is 2 here, right? This here is also 6 and so on, right? Now that means that every small line represents, how much is that? That's 4, right? So every small line represents 0.4, right? So you need to understand your scale before you can plot this, eh? So I'm plotting 4 against 18.4, right? So 4 against 18.4 is going to be 16, 18. 18.4 is actually about here, right? So you all need to get into the habit of try to get some practice plotting points, right? So that is 18.4. Make sure that's correct, 18.4. Let's double check the scale. 4, 12, 16, 20, 24, 28. Yeah, that seems to be right. The next point we're going to plot is 8 against 20.5. So 8 against 20.5 is somewhere around here, right? It's just above this point here. Next point is 12 against 22.4. So 12 against 22. That's what, this point here. Alright. Right now looking a little funny, but let's check again. 16 against 24.3. So 16 against 24.3 is about here. Right, that's about here. That's this. 20 against 26.4. So 20 against 26.4. So this is 26 here. 26.4 is this value here. Right? And then this one here is 24 against 20.5. So 24 against 28.5 is about here. Right? I hope you all see the red dots. Then 28 against 31.3. So 28 against 30. This is 31. 31.3 is about here. Right? That's about here. 31.3. And then the last point here is 32 against 36.4. So 32 against 36.4 is this point here. Right? Alright. So, alright. So that's what I get in here. Let me make sure that's correct. 4, 8, 12, 16, 20, 24, 20, 32. I just find it now looking like a smooth curve now. A smooth line, right? I just double check this. 4, 8, 12, 16, 20, 24. .4. Oh, okay. I just saw a slight error here, right? So this point here, I just plot this point in the wrong spot. So let me just draw over that. That is 8 against 20.5. 8 against 20.5 is about here. Right? So you realize that it's kind of start off like a straight line and then it start to curve a little bit. Right? So let's see what they want us to do. They said use a graph, plot a graph. Right? So let's plot a graph. So first things first, we're going to realize that here what? We have a straight line part and we seem to have a curved part as well. Alright, so alright, so right, so that's the first part of the graph. So that's kind of straight line region of the graph. But then if we extend this, maybe I could draw a smoothish kind of curve here. You realize what's happening. The graph is starting to curve upwards. right? That's what's happening to the graph here, right? So you're going to use your ruler and you're going to try to, sorry, a pencil, and draw a smoothish curve, right? That's what's going to happen here. Now, if you go back to what I told you at the beginning, if you plot extension against load or extension against force, this is the graph that you're going to get, which is what the data is also showing us. So that's what we got, right? It's not a perfect straight line. We get a straight line up to a point, right? So that's my graph. The next thing I want to know, find the slope of the graph. Now, we can only find the slope of the graph for the straight line part of the graph, right? That's what you can do. So what I'm going to do, like in the previous question, I'm going to choose 2 points that are not the points that we plotted, right? So I'm just going to choose 2 points. Let's say I'm going to choose this point here, which is going to be, that's what, 6. That point is going to be 6, and that value there is going to be 15.4, 15.8, 18.4, 18.8, 19.2, one second, 15.4, 15.8, that is about 18.4, 16.8, 17.2, 17.4. Just give me a sec, right? Let me just double check something here. Right, so 18.4, 18.8, 19.2. Yeah, actually it's not, that's not 18. Say not wrong. Not correct. Hold on. So that's about 19.2, right? And then I'm going to choose some other point here. Let's say 22, and maybe this point here, right? So this point here will be 22 against, and that's 26. So that's about 27.6, around it, right? So you all have to choose 2 points on your graph. You need to find 2 points that easily, you can read it off easily, right? So the question wants to know, find the slope of the graph. So I'm going to write down what those 2 points are that we just chose. So that is 6 against 19.2. So the first point is 6 against 19.2. And the second point that I've chosen is 22 against 27.6. So 22 against 27.6. So 22 against 27.6. Right? Those are my 2 values. Now, next thing we need to do, we need to label the points. Once you find a slope, always label your points. So this is x1, y1, x2, y2, right? And now we're going to find our slope. So slope, right, is given by the formula y2 minus y1 over x2 minus x1. That's our formula we're going to use. So we're going to plug in values. It's going to be 27.6 minus 19.2 all over 22 minus 6, right? So guys, you all can try back the question, right? In terms of, remember I'm trying to draw it on a screen here, right? Not actual graph paper. So you might get something slightly different. So 27.6 minus 19.2, I'm going to get 8.4 over 22 minus 6, you're going to get 16. So it is 8.4 divided by 16. 8.4 divided by 16, and I'm going to get 0.525. Right? And again, we could give a unit. If you look at your graph, you have millimeter here and you have Newton. Right? So your unit is going to be millimeter per Newton, right? That's going to be my unit, millimeter per Newton, and that's it. Just like in the previous question, they want you to get a spring constant. So my spring constant right is 1 over s, right? They told us that. So all we need to do is to take the answer we just got, the 0.525. So it's 1 divided by that. So 1 divided by 0.525, and you're going to get 1.9. At least that's what I'm getting using my data, right? So 1.9, and in this case your unit here is going to be Newton per millimeter. That's my unit. So 2 marks for that, guys, right? 2 marks for that. Right, 1 second. I know checking the messages here. Let's go back to the graph here. Let's see what you all said. There's a mistake in the graph. Oh yeah, I know seeing what you all say. Yeah. So you're going up in 4s, 4, 8, 12, 16, 20, 24, 28. Yeah, this should have been 32. Thanks for that, guys. Right? But it's not going to affect the answer because I didn't read anything from that part of the graph. Yeah. Good spot, guys, right? So let's just remove that piece here and let's just plug back those points. Right? Let's see, 24 against 28.5. Right, that's about here. 28 against 31.3. That's about here. And then 32 against 36.4. Right, so thanks for that, guys. Right, so the graph looks more like this, right? So that's the only change you're making it. But I didn't choose any point there in order to figure out my gradient, right? So thanks for seeing that, guys, right? Right, now let's see what they want us to do. Use the graph to determine the spring's length when the load is 0. So all they want us to do here, they want us to read off what this value is here. Where am I cutting my y-axis? Because remember, that corresponds to 0 load, right? So that is going to be 16.4 millimeters, right? If you read off that, that's going to be 16.4 millimeters. Okay? Next thing they want here, what is the value of the spring's extension when a load of 14 newtons is attached, right? So when 14 newtons is attached. So I just go back to the previous graph here. I just want to borrow one of these lines. So you want 14 newtons, right? So if you come back here, I want to get 14 newtons. So I need a vertical line at 14. Alright, I need to come up to the graph here. Alright, sometimes these lines don't do what I want them to do. So you're reading off at 14, right? So you're reading off at 14 here. Right? Then what we need to do, we need to draw a horizontal line to read off what that length is supposed to be. Now, one of the reasons why I chose this question here is that you need to understand what you're actually doing here, right? So I'm trying to read off this here from the graph. Okay, sometimes these lines not doing what I wanted to do, but this is what I'm reading off here. So when I read that off, I'm reading off this value here from the graph, right? That's what I'm reading off. So that is around, that is 22, 22.4, 22.8, 23.2. So that's around 23.2 millimeters, right? So that's my length. So from the graph, L is equal to 23.2 millimeters, right? But here's the thing, this is not the answer, right? That's the total length of the spring. So you see, you notice what CXC did here? They put this in bold. So my actual extension, right? So my actual extension is going to be equal to my reading that I'm getting right now, which is 23.2 millimeters, right? And I must subtract the original length of the spring, which is 16.4, right? We got that up here. We got 16.4 up here. So it's 23.2 minus 16.4. 23.2 minus 16.4. And you're going to get 6.8 millimeters as my extension, right? Let me just check the chat, see. Right, somebody asked where I got the 16.4. I got that from the graph. From the graph here, this, your y-intercept on the graph is actually the length of the spring, right? That's when I have no load attached to it. That's where I got 16.4 from, straight from the graph, right? So be prepared if you get a question like that. Sometimes they can make you plot extension against force, or they tell you plot the length against force, right? So this graph didn't pass through the origin like the last one. Now then, so even more stuff now. What mass must be placed on the spring to produce an extension of 9 millimeters? So this graph here only gives me full length of the spring, right? It gives me the length of the spring as well as the extension in one value. So what I need to do, first of all, so you want to produce an extension of 9 millimeters. I can't go to the graph and just read off 9 millimeters, right? What we have to do, right, because they said is the extension, you need to find the total length, because that's what the graph is giving me. So my total length, so be careful with questions like these. It is going to be my length of my spring, which is 16.4. So it's going to be 16.4 millimeters plus 9, right? So 9 and 6 is 15. So this is 25.4 millimeters. So I need to go to the graph now and try to read off where is that 25.4 millimeters. So you go to the graph. So you want 25.4, right? So let's see if I can figure out where 25.4 is. So I need to do this, guys, because when I try to draw the horizontal line, it's drawing slanted. So this is 24.4, 24.8, right? And that is 25.2, right? And then this here in the middle is 25.4. So you're reading off 25.4 here, and if you look carefully, what is happening, that is actually going to be this value here. So I'm getting actually 18 as my reading here, right? I'm trying to get the line as horizontal as possible. So what I'm doing here, I'm reading off this value here, which is 18, right? So this here, so my graph gives me load in newtons, right? So my load, right, is equal to 18 newtons, right? But notice what it said. They want to know what mass is attached. So this is where this formula comes in again. W is equal to M multiplied by G. So my mass has to be equal to my weight divided by whatever G is. So my weight, in this case, is 18 newtons. That's the load we would have attached. And you divide it by 10. So your actual answer is 1.8 kilograms, right? 1.8 kilograms. So be careful with how these questions are asked, right? Alright, so I hope you are not too lost. Right, And last part, describe the procedure that the student may have used to obtain the results, state the precautions, blah, 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 blah. So basically, it's the same diagram we just drew, right? The same diagram that we drew in the previous question. So I'm not going to draw it back again. This is the diagram they want. You just need to describe the procedure. So what you would do is draw the diagram and say, set up the apparatus as shown. And basically, you're going to measure the length of the spring without any load, right? And then you're going to keep adding loads and keep measuring the length, the total length of the spring. That's essentially what you're going to do. In terms of experiment, precaution, you need to make sure that the meter rule is as vertical as possible. Make sure the spring is vertical, right? And you're going to take all readings at eye level. So any experimental precaution you can use for this, right? Another precaution is to use, make sure you have on goggles when you do this experiment, because the spring, what if the spring snaps and the spring could damage your eyes, right? So those are experimental conditions that you can use. So you're reading at eye level, make sure the meter rule is vertical, make sure the spring is vertical, right? In this case, we're using a pointer. We need to make sure that this pointer is horizontal, and please wear goggles, because if it snaps, then you're going to have problems, right? You could damage your eyes. So we've just done 2 questions based on Hooke's law, right? And I hope you all kind of following. Somebody asked, why was the 4 added to the total length again? The 4. Which part is that she's referring to? You mean the 16.4? You see this 9 millimeter here, this is extension, right? That is not total length, that is extension of the spring. You know what the original length of the spring is. It's 16.4. So therefore, to find the total length, that is the length of the spring plus the extension, you need to add it. Because that's what the graph is giving us. This graph is actually giving us this here. This is not extension. This is total length. That's what this is. Total length. Right? And that's why the graph doesn't pass through the origin. Right? Because that length includes the length of the spring inside of there. Alright, so Sophia, I hope you kind of get that. Alright, so just to let you guys know, if you haven't subscribed to my channel as yet, please hit like and hit subscribe if you like what I'm doing, right? I'm just letting you all know that I do give online classes in maths, add maths, chemistry and physics, right? I know most of you all are writing exam now, right? But I have a new class starting from August, right? You all can give me a contact at this number, right? You can send me a WhatsApp for anybody you know interested in maths, add maths, physics and chemistry. I personally teach all those subjects, right? It's not done by anybody else but me, right? Alright, so the next thing I'm going to be looking at is moment of a force and the principle of moments, right? So this is what CSEC said. They said that we may be getting a question on turning forces, right? And these are some definitions you guys need to know. So the first thing that CSEC can ask you is explain what is meant by the moment of a force. Now, some students, they confuse moment and momentum. Those are 2 different things, right? When it comes to the moment of a force, you can draw a simple diagram for them, right? So that is my pivot. This is a force that is acting at right angles to the line of action to where the pivot is. So this is my force here. This is my distance, my perpendicular distance from my pivot. So the moment of a force, T, is given by F multiplied by D. That is what is meant by the moment of a force. So, in terms of words, again, no old talk in the exam. Your definitions need to be precise if you want to get full marks. So, the moment of a force is the product of a force multiplied by its perpendicular distance from the fulcrum. That's what this diagram is showing. That's what this diagram is showing here. So, that's my definition. Don't give anything in your own words. That's not what they want. They want the exact definition. The next thing you have to be able to do is to state the principle of moments. So the principle of moments states that when a body is in equilibrium, the sum of the clockwise moments about a point is equal to the sum of the anti-clockwise moments about that same point, right? Again, word for word, right? Word for word. Don't try to give them something in your own words, you might get it wrong, right? So this is the definition. I am giving you what the definition is supposed to be. If CXC asks you, just state this, learn this off if you have to, because these are the things that they said are going to come. The next thing, sometimes CXC asks you, what are the conditions for equilibrium? Now, when we say an object is in equilibrium, right, that means that the resultant force acting on this object or this body is zero. So that's my first condition. The resultant force acting on the body is zero. The second condition for equilibrium is essentially the principle of moments. The sum of the clockwise moments about a point is equal to the sum of the anti-clockwise moments about the same point. So if you do get a question on moments, these are the things that you need to know. This is simply what we call a recall, meaning that this is all it can ask you when it comes to the definition. So you just need to learn this off, right? You have to just learn it off. Oh, somebody's asking about, right, so I just send a message, right? So let's go back to, so let's look at some actual exam questions now, right? So this is January 2017. So this is a relatively recent paper. They said fill in the blanks following the passage about moments of forces. So if you look at this passage that they have here, you realize, and for 4 marks, 4 marks. The something of moments states that when, so this is exactly what the principle of moments is. So this here is the principle of moments states that when a body is in equilibrium, the sum of the clockwise moments, so all you do is just pulling out this, you know. Clockwise moments about any point, I don't know why they give you all this space, right, is equal to the sum of the anti-clockwise moments about the same point. So all we needed to do here was fill the blanks, fill in the blanks, and I get 4 marks just for doing that, right? Now, so you have to learn off your definition, right? Not much I could help you there with that one. Next part, apart from the seesaw, identify 2 situations in which a force will result in a turning effect. So whenever you apply a force to somebody that has a pivot, right, that force is going to have a turning effect. It's going to start to rotate, either clockwise or anti-clockwise, right? So situations where we have this taking place, right? Now they just want 2, right? So opening a door, as an example. Opening a door, right? So if we have, let's say you have a doorway here, right? And you have a door here. And I come and I say here what? I want to open this door. So the door handle is here. When you apply a force to this door handle, the door is going to rotate like this, right? So this is my pivot here. This is my hinge, right? So this is what's going to happen. You're going to have a turning effect, right? So that's opening a door. A next example, if you take a can opener and try to open a can, right? Let's say you have a can here. How do I draw this by? Right? So let's say you have a milk can or something like that, right? And you want to pry it open. You can put a knife here, right? And what you could do, by the way, this came as a CXC question already. So if you apply a force here, right, you're going to pop the lid out, right? So using a knife to open a tin, right? So using to open, right, a tin can, right, with a cover. Let's use the wood with a cover, right? Your forearm lifting an object, right? So your forearm right? So they just want any two examples or any two situations. So you put whatever you want, right? Once it makes sense, right? Any two situations. Now let's see the calculation part, right? The calculation and what tends to give students some trouble. So we have two guys here. We have Kyle and Keon, right? They balance on a seesaw, right? Even though the diagram is not showing that, right? But they say they balance on a seesaw, and Kyle's weight is 500 and Keon's weight is 300 newtons. The seesaw is made of a uniform plank of weight 800 newtons, which is 4 meters long, right? Pivoted at its center. Now the question says, by taking moments about the pivot, calculate. Okay, so before we can even do anything, let's draw a little sketch, right? Let's draw a little sketch to help us understand what is happening here, right? I'm going to put all the information on the diagram. So you have a plank. They told us the length of the plank, I think. Yeah, they said it's 4 meters, right? And now they said it is a uniform plank. You see this here? This tells me something. When they say the plank is uniform, it means that is where the weight of the plank is acting. So this weight of 800 newtons is actually acting at that point here, right? So in terms of dimensions, this here has to be 2 meters, right? And from here to here, that also has to be 2 meters. So the fact that the plank is uniform tells me that the weight is at the center of the plank. Now, they said that Kyle and Keon, they're on the seesaw. Kyle's weight is 500, Keon is 300. And the seesaw is made of uniform and it's pivoted at its center. So what that means is that we have a pivot at that point here, right? And let's see what else. By taking moments about the pivot, calculate the distance x that Keon must sit from the pivot. So Keon is somewhere here, right? Here on the left hand side. We know what Keon's weight is. Keon's weight is 300 newtons. So this here is Keon's weight, 300 newtons. And he's at a distance, right? So x is the distance from the pivot. So this is this distance here. From here to here is x, right? That's what you're trying, that's what we don't know. We don't know what x is. And where is Kyle? Kyle is sitting where? Keon must sit from the pivot to balance the plank if Kyle sits 1 meter from one end. So if he sits 1 meter from one end, this is 1 meter here by the way, 1 meter. So who is this one sitting there? This is Kyle, right? So Kyle is sitting there and Kyle's weight is 500. So this here is 500 newtons, right? So that's my diagram. You need to take the information that they've given to you in the question, right, and put that in a diagram. So let me put this diagram on the next page here. So this is my diagram, right? And you want to find what is the value of that x. So we're going to take moments about the pivot. I'm going to take moments about the pivot, so I'm going to say that. So taking moments about the pivot. So taking moments about the pivot, right? Remember, you must take into account clockwise moments and anti-clockwise moments. So clockwise moments is equal to, is already sum of, right? So sum of clockwise moments equal sum of anti-clockwise moments. Right? All moments questions typically start off like this. You need to say where you're taking the moments about, and you need to put sum of clockwise equals sum of anti-clockwise. Now, this is my pivot here, right? The center. This 500 Newton is going to tend to move in that direction, so that's a clockwise moment. So therefore, remember, moment is force by distance from a fulcrum. So this is going to be 500 multiplied by 1, right? Because this distance here has to be 1 meter. This distance is 1 meter as well. All right, and that's the only clockwise moment you have. The 300 Newton is going to rotate this way. So that's an anti-clockwise moment. So this is going to be 300 multiplied by x. So if we rearrange this, we can say that x is equal to 500 divided by 300 and therefore x is equal to, what is that, 1.67. So this here is 1.67 meters, right? That's my answer, 1.67 meters, right? Right, somebody is asking if the live will be up later. Yes, it's been recorded, so it'll be up later. So honestly, if you get a question like this in the exam, this is a very easy moments question, right? It could get a little more complicated, but this one is very, very straightforward. Let's see. If balance, calculate the reaction force at the pivot. So here's what we're going to do. I'm going to just draw back the pivot here. I'm going to just draw some of the forces for you guys. So we knew that the weight of the plank, they told us the weight of the plank in the beginning of the question, it was 800 newtons. So this here was 800 newtons, right? And we had, I can't remember the guy's names now. Keon is 300 newtons. So Keon, so this force here is 300 newtons. Right? And then on the right hand side we have Kyle, who is 500 newtons. So Kyle, he sits somewhere here and it is 500 newtons, right? And the question says, if balance, calculate the reaction force of the pivot. Now if you look here, all these three forces acting downwards, right? The plank is not falling to the ground, which means at the pivot there has to be a reaction force acting upwards that is balancing this. So if you want to get what that reaction force is, that's my upward force. R has to be equal to 300 plus 800 plus 500, and that's going to give me what? 5 and 3 is 8, that's what? 1600 newtons, right? 1600 newtons. And look at that, 4 marks for that, guys. So if you want to put a proper statement, you can say total upward force. So total upward forces equal total downward forces. Right? So this is a very easy calculation if you know what you're doing in this case here. And then the last part here, they said, what is the moment of the reaction force about the pivot? Y'all feel you can answer that for me? What do you think is the answer for the third part? Nobody want to take a shot at this? So here's what's happening here. Remember, to find the moment of a force, right? The moment of a force is, the moment T is equal to force multiplied by distance, right? Now, this force that we just worked out here, that R is actually at the pivot. So the force R is 1600 multiplied by my distance from your pivot, which in this case is going to be 0. So my moment is actually going to be 0. So my moment of the reaction about the pivot is 0 Newton meters, right? So by the way, I forgot to mention this, the moment of a force is measured in Newton meters, right? That's how we measure that. So all in all, this was a very straightforward question. Like I said, I've seen more complicated questions in the exam, right? So let's go back to with our next question here. This is an older paper, right? Actually, this, surprisingly enough, this is the this question is what I got in my exam, right? A long time ago, right? So we have a forearm, and they said the forearm is a lever in which the bicep muscle provides an upward force which can raise the arm and carry a load. The diagram below represents the forearm as it holds a load of 60 newtons, right? The forearm's weight is 25 newtons and the center of gravity is G. So basically they give us some information here, and everything that they told us is on the diagram, right? So you can visualize it, you can look at it, and you can check it out, right? So if you look at it, this is your arm, and if you're lifting something, your arm needs to do this. So this muscle here, your bicep, needs to pull your forearm upwards, right? That's what needs to happen. So let's see what is taking place here. So they said, using the principle of moments, calculate the force B exerted by the biceps. So that's this force here. We need to figure out that force needed to lift or balance the forearm, right? So they said they want to keep the forearm and the load stationary, meaning that it's going to stay horizontal. So let's work that out. So we're applying the principle of moments. So what you need to do when you get a moments question, you need to decide, where am I going to take my moments about, right? So in this particular question, right, you can decide to take your moments about, let's say, G if you want, right? You can take it about P. You have to decide which point makes the most sense to you, right? But since my pivot here, right, my elbow is my pivot, I'm going to use that as my point where I'm going to take my moment. So I'm going to take moments about P. So all questions start off this way. Taking moments about P, right? That's what we're going to take moments about. And we do the same thing we did in the previous question. So we're going to say total clockwise moments right is equal to your total anti-clockwise moment, right? Or you could put sum of, it doesn't matter, clockwise alright. So if I'm taking moments about the point P, as this point here, you need to figure out what are my clockwise moments and my anti-clockwise moments. In the case of the force B, this force B is pulling upwards like this, so therefore that's an anti-clockwise moment. This 25 Newton is rotating this way, so that's clockwise. 60 is rotating this way, so that's clockwise. So the first thing you need to do is to identify what is clockwise, what is anti-clockwise, in reference to your pivot, right? So my clockwise moments in this case here is going to be 25. You have a 25 Newton force multiplied by its distance from the pivot, which is 0.2, right? But we have an next clockwise moment, so we have to add, and we're going to add 60, right, multiplied by your distance from your fulcrum. That is this distance here that we need. So that is 0.2 plus 0.15. So this is 0.35. Close brackets, equal. Anti-clockwise moments, we only have one. So that force at B, we're going to call it B because we don't know what it is, multiplied by 0.05, right? So now we need to use our calculator and start simplifying. 25 multiplied by 0.2, in this case here you're going to get 5, plus 60 by 0.35, so 60 by 0.35, you're going to get 21, which is equal to 0.05 B, right? So this is 26 is equal to 0.05 B, right? So I'm gonna just shift up here so I can work that out. So therefore B is equal to 26 over 0.05. So that is going to give me 520 newtons. So that's a force I'm going to need to apply in order to keep the forearm stationary. Right, so I hope you all follow that one there. You need to be able to take the moments about a point, right? Identify what are your clockwise moments and your anti-clockwise moments. right? So that's my answer here, 520 newtons, right? So that is this part here. In part 2 now, they said the adjoining bone pushes down the forearm at the point P with a force R. Considering the upward and downward forces, calculate R. So what they're saying is that if this muscle, the bicep, is pulling up at B, the bone at the forearm has to be pushing down here with a force R. So what they want us to do is to figure out what this force R is. And they kind of give us a hint to it. They said, considering the upward and downward forces, calculate the value of R. So you have a force here acting downwards, which is R. You just worked out what B was. B was 520 newtons. So this here is 520 newtons. So all we need to do, we need to figure out what R is. So all we need to do is say total, just like the question before, total upward forces equal total downward forces So my total upward force in this case here is only B, which is 520 newtons. So this is 520 is equal to my downward force, which is R, plus you have a 25, plus you have a 60. So all we're going to do, we're going to just rearrange this. So R is equal to 520 minus 25 minus 60, and therefore R is equal to you get 435. So this here is 435 newtons, right? So again, this is an exam question based on the principle of movements, right? So we had to work out the force exerted by the bicep, and we had to find the downward force at the elbow, basically. All right. So I have a few more examples. We're going to do them. So in this question here, we have a wheelbarrow. And by the way, this wheelbarrow question came more than once. I've seen they brought this question more than once in the exam. So you have a container and a load. So you have a load of sand in the wheelbarrow, basically. The pivot is at P. So this is my pivot here, right? And, right, so they told us the mass of the container and the load. So we know it's 40 kilograms. The center of gravity is G, and it's 0.5 meters from P. So basically, everything that it's telling us here in words, it's on the diagram already, right? The handles are being held so that the wheelbarrow, so look at this, they said the wheelbarrow is in equilibrium, meaning that somebody's holding the wheelbarrow and it's not moving at all, right? So first part they want us to calculate the upward force which is being provided by the handles. So let's go to this diagram here. So they told us in the question that the container and the load, so this is important, container and the load, it's pivoted at P, but it has a mass of 40 kilograms. So therefore, if you go to this diagram here, your mass is equal to 40 kilograms. Now when you're dealing with questions involving moments, right, we're dealing with weight, we're dealing with newtons. So weight is equal to M multiplied by G, which is 40 kilograms multiplied by G, which is 10. So therefore, this is 400 newtons. So what that means is that at this point here, my center of gravity, I have 400 newtons acting like that, right? That's what we have. Now the question, the first part, they said calculate the upward force, right, that is provided by the handles. So you have a force here that is acting upwards, right? So let's call that F, right? We don't know what that is. We're going to figure out what that is. Now, what I'm going to do, I'm going to take my moments about my pivot. That's the axis of the wheelbarrow. So when we look at the forces, you realize the 400 newtons is a clockwise moment, and this one here produces an anti-clockwise moment. So I'm going to say taking moments about the point P, right? We take a moment about the point P here. So we're going to say sum of clockwise moments equal the sum of the anti-clockwise moments, right? Right? So you sum your clockwise moments. We only have the 400 Newton acting in a clockwise direction. So that's 400 multiplied by 0.5, right, is equal to F multiplied by 1.4. So therefore, F is actually equal to 400 multiplied by 0.5 divided by 1.4, right? That's how I'm going to get my value for F here. So that is 400 multiplied by 0.5 divided by 1.4. And what I'm going to get here is approximately 143 newtons, right? So that's my value for my force, 143 newtons. Right, so that is this part here. The next part we need to work out now. They said calculate the upward force at the axle P of the wheelbarrow. So let's go back to our diagram again. So again, we just worked out this force here, right? And that was 143. So this here is 143 newtons. We had this acting downwards here, which was 400 newtons, right? And what they're telling us is that we have an upward force at the axle P. So you have an upward force here, right? You have an upward force here at P, right? So I'm going to just call that force P for now. So what they want us to do is to figure out what is that force. So just like in the two previous questions, we're going to say our total upward force. So your total upward forces equal to my total downward forces. Right? So your total upward force, you have two forces acting upward, which is P plus the 143, which is equal to my total downward, which is only 400. So therefore P is simply equal to 400 minus 143. So therefore P is equal to 257 newtons, right? 257 newtons. All right, so that's my answer for that question there. So we have a next example here, right? Forgot to write down what year it was, but there's the next one here. So you have Kenny and Candy, right, decided to sit on a seesaw while visiting a local play park. These are past exam questions, by the way. Candy has a mass of 50 and she sat 250 centimeters from the pivot of the seesaw. Where should Kenny, who is 60 kilograms, sit so that there is a state of equilibrium? So what's happening here is that you have a seesaw, right? So you have a seesaw here. Typically a seesaw is balanced at the middle, at the center. So let's see. So Candy has a mass of 50 kilograms and she's 250 centimeters from the pivot. So she is 250 centimeters from the pivot, right? So this Candy on the side here. And she has a mass of 50 kilograms. Now remember, when you have questions like this, we're dealing with forces. So her weight is equal to m multiplied by g, which is 50 multiplied by 10. G is taken as 10, and this is going to be 500 newtons. So we concern about her weight, not her mass. So this here is going to be 500 newtons, right? So this is Candy on this side. Then on the right hand side now, we have Kenny, who has a mass of 60 kilograms. So in this case here, Kenny, his weight is going to be 60 multiplied by 10, which is 600 newtons, right? So that's Kenny's weight. Now we don't know where he's sitting, right? Because that's what the question trying to ask us to figure out. So this here is 600 newtons, and what's happening here is that we need to figure out what is that distance here, right? We need to figure out what is that distance. So again, we're going to apply the principles of moment, and we're going to take the moment about the pivot again. So if you do that, the 600 is going to be clockwise, and the 500 is going to be anti-clockwise. So actually I could just work this right here. So what we're going to do, we're going to say 500 multiplied by 250 centimeters. Now, when we work in moments, we tend to work in meters, right? So this is 0.25 meters, which is equal to 600 multiplied by x, which we don't know. So therefore, x has to be equal to 500 multiplied by 0.25 over 600. So therefore, x is equal to 500 multiplied by 0.25 divided by 600, and you're going to get 0.208. So this is 0.208 meters, right? Or if you worked out your answer in centimeters, it'll be 208 centimeters, right? So any one of those will be fine. So that's my answer for the first part, right? That is, where should Kenny sit? So he should sit 208 centimeters from the pivot, right? What should Kenny do if he wanted to elevate Candy? Right now, as it is balanced, meaning that the seesaw is horizontal. Now, if you want Kenny to elevate Candy, meaning you want it to raise above the ground now, what do you all think Kenny needs to do? Anybody want to try that one? What do you think is the answer for that one? If you want to make Candy go up in the air, what does he need to do? I know I have some students from my online class here. Anybody want to try that one? I've seen Daryl here. I've seen Alex here. Sophia also here. What does he need to do? So I see Christian says go backwards, increase the mass or the perpendicular distance. Well, the thing is, he already has a fixed mass, right? So he's not going to increase his mass, right? So you said perpendicular distance. Yes, all he needs to do is to move further away from the pivot, right? That's all he needs to do. He needs to move further away from the pivot, right? Now, I want you all to get into the habit of looking to see how many marks they're giving you for these things, right? Look and see how many marks they're giving you for this. So for this part here, they're giving you 3 marks. So they said, what should he do? All he needs to do is to move further away from the pivot, right? So that's your answer. Move further away from the pivot. That's what he needs to do, right? And the reason for doing that is that you're going to increase the size of your clockwise moments, right? So your clockwise moment is going to increase. So you need to say that as well, because you notice it's 3 marks. You can't just say move further from the pivot. If he moves further from the pivot, it means that his clockwise moment is going to increase. And therefore, because the clockwise moment is greater than the anti-clockwise moment, right, Candy is going to raise, right? So look at the marks. Don't just rush to answer questions. So our next one here, next recent one. Oh, and by the way, in the 2021 paper, right? They brought a question on moments in the 2021 paper, right? I didn't put that question here. I worked that in class with my students. We did the whole of the 2021 paper, the January paper that is, right? So here's what's happening here. So Patrick and Patricia showed their class a magical balancing act. They both sat on one side of a uniform plank, right? A 6-meter long plank. Patrick is 1 meter from the pivot, sorry, located 0.5 meters from the center. So okay, so we're just reading the information here, right? So Patrick sat 1 meter from the pivot, located 0.5 from the center of the plank. Patricia is 0.5 meter from the pivot on the same side. So basically what's happening here in this diagram, both of them are sitting on the left hand side here, yet the plank is balancing, right? That's why they call it a magical balancing act here, right? You expect the plank to tumble, right? But it's balancing. So they said in part 1, label as W the point on figure 2 where the weight of the plank acts. So the weight of the plank obviously has to act at this point here, right? The weight of the plank, they said, is at the center of the plank, right? So W is at that point here. So 1 mark just for labeling that position. The next thing they want us to work out is to calculate the weight of the plank. So let me go on a diagram, a separate diagram here. So this is what we want. We want this value here. This is the weight of the plank. So we need to look at all our forces. You have a 500 here, you have a 400 here, right? And we have W, which we don't know what it is. So you need to decide where you're going to take your moments, right? So I'm going to taking all questions, you need to tell them where you're taking your moments about. So taking moments about the pivot, right? I'm taking it about the pivot. That's this point here. This point here, I'm taking it here. Right? We're going to say the sum of clockwise moments is equal to the sum of the anti-clockwise moments. Right? So my clockwise moments here, now if this is my pivot, it means that W is a clockwise moment. It also means that the 500 is anti-clockwise, and it also means that the 400 is anti-clockwise. So my only clockwise moment here is going to be W multiplied by 0.5. That's my distance from my fulcrum, which is equal to my anti-clockwise, which is going to be 500 multiplied by 1 meter. Right, but we have our next anti-clockwise moment, which is the 400. So that's 400 multiplied by 0.5. Right, so this is 0.5 W is equal to 500 plus 200. Right, 400 by 0.5 is 200. So therefore, W is going to be equal to 5 and 2 is 700 divided by 0.5. Right, which is equal to 72 is 1400 newtons, right? So that's my value for the weight of the plank. The weight of the plank is 1400 newtons, right? So that's part 2 we just worked out, the weight of the plank. Now the third part now, they said if Patrick sat alone on the plank, calculate where he would have to sit in order to maintain this magical balance, right? So the pivot remains as before. So what they're saying is that Patricia is no longer there, but we just have Patrick. So this here no longer exists, right? So she's no longer there. So what's happening is that Patrick now, in order for him to balance this thing, he needs to be at a different distance from my fulcrum, right? He needs to be further this way. He needs to move back in order to balance this thing now, right? So Patricia is no longer there, and we need to figure out how far should Patrick be from the pivot, right? So you want to work out this distance here. Let's call that y. I'm going to call that y, right? So I'm going to do the same thing as we did before. We're going to take moments about this pivot here again, right? You know what the weight is. You worked out that before, and you got, what's the answer for that one? 1400, right? Your weight is 1400. So this here is 1400 newtons, right? So we're going to take moments about the pivot again. So taking moments about my pivot, right? I didn't realize they had a name for it. They call it X, right? So taking moments about the pivot X, right? So your sum of your clockwise moments equal to the sum of the anti-clockwise moments, right? So you sum your clockwise moments. The 1400 is acting clockwise, and this 500 is acting anti-clockwise. So this is going to be 1400 multiplied by 0.5 is equal to my anti-clockwise. The only anti-clockwise moment that we have here is the 500. So this is 500 multiplied by y. You don't know what y is. So therefore, y is equal to 1400 multiplied by 0.5 over 500, and that's going to give me, so that's 1400 multiplied by 0.5, and you're going to divide by 500, and you're going to get 1.4 meters. So this here is 1.4 meters. So that's how far Patrick needs to be from the pivot in order to balance this thing. All right? All right? So guys, this brings me to the end of my first free session, right? So I covered several different things here, right? So if we go back to the beginning, right? We are basically using the broad topics that CSEC gave us to work with, right? So we looked at Hooke's law. I gave you all the definitions that you all need to know. You need to be able to describe an experiment in order to explain how we collect data for Hooke's law. That's important. You need to know what the graphs look like. So I did two different kinds of questions for you all here, where we measured total length of the spring, and one where we measured the extension only, right? So the first question we did was extension only. The second question had to do with total length, right? So make sure you know how to draw these two types of graphs. I showed you how to calculate the slope, because if you do get a question on Hooke's law, chances are you will be asked to find the gradient and to figure out what the spring constant is for that spring, right? I showed you how to read off different things from the graph. So what you can do, you know which years the questions are from, right? So please go through the questions again, right? And see if you can get the same answers that I'm getting. We also looked at the moment of a force. Make sure you know your definitions. You need to know what is moment of a force. You need to state the principle of moments, and you also need to state the conditions for equilibrium, right? And we did several examples as to how we're going to apply the principle of moments, right? And like I said, they brought a moments question in the January 2021 paper, right? So I was kind of surprised that they actually said we're going to get that again, right? Now, for all you know, it could be a small question, right? It may not be a full question, but it may just be a small question. We don't know, right? So, like I said, guys, this brings an end to the first free session, right? The next session will be held next week, Tuesday at 3 o'clock, right? So I'll go through something else at that point in time. So I hope to see you guys there. right? So feel free to share the link to the video. It's gonna be it's being recorded, so you can access it after if you want to, right? Like I said, feel free to share. Just click like, subscribe to the channel, pass the word around, right? I hope the session was good for you guys. All right, I'm seeing some people say they can mash up these questions now. They're easy. All right. So guys, take it easy. Enjoy the rest of your afternoon, and please be safe, guys. I think somebody asked what topic I am doing next week. Just now, I have the listing here. Oh, the next topic that I'm going to be looking at will be waves and ray optics, right? I think that's the. Okay, so actually, inertia and the gas laws, or waves and ray optics. One of the two. I haven't decided which one is it, right? But one of those I'll be teaching next week. So please continue studying your work. Exam right around the corner, guys. All right, so take care, everybody.